Hello, my name is Ken Adams, and I'm a geology professor at the Desert Research Institute in Reno, Nevada. And at this site, what I want to talk about is glacial outburst floods that came from Lake Tahoe, coursed down the Truckee River. Downstream is to my left, you're right, and eventually ended up in Lake Lahontan. And so, what do I mean by glacial outburst floods? Well, I should first back up and say where we are. We are on the left bank of the Truckee River, near Mustang, Nevada. I-80 is right behind me. The Truckee River is just downslope in front of me. I'll walk around a little bit and show you the setting in a couple of moments. So this is the Truckee River. It flows out of Lake Tahoe, which is in the Sierra Nevada, at an elevation of something around 6,200 feet. And it flows, I don't know, 175 miles perhaps. Maybe not that long. Look on a map. Anyway, it flows into Pyramid Lake, which Pyramid Lake is a closed basin. The only way that water gets out of that lake is through evaporation. And so that lake fluctuates with the long-term wetness, or how much precip is occurring in the Truckee River basin. And it is a remnant of Pleistocene Lake Lahontan, which occupied this basin. Reached its high stand at around 15,000 years ago. I hope my dogs don't knock over this tripod. And it came up to about here in the Truckee River Canyon. The lake was covered about 20,000. I'm going to get all these numbers all messed up, out of practice. 20,000 square kilometers or so. Anyway, at the same time that this gigantic lake was down here, of which Pyramid is a remnant, there was a large ice cap on the crest of the Sierra Nevada. And some of those outlet glaciers that came down Bear Creek and Squaw Creek, which are just downstream from the outlet of Lake Tahoe, big ice tongues came off the ice cap and dammed up the Truckee River. And ice, of course, doesn't make a very good dam because it floats. And so when enough water is backed up behind this ice dam, it'll float the dam and the water will rush out and off it goes. And so these are called glacial outburst floods, or Jakalaps. Jakalap is an Icelandic term. I'm not going to spell it because I can't off the top of my head. And so how do we know all this, that there were these big outburst floods? Well, this was figured out by a guy named Pete Birkeland, who's now Professor Emeritus from Boulder. And this was part of his dissertation work, or he was doing it at about the same time for the 1968 INQUA meeting that was in Reno. And so he was mapping glacial deposits up around Tahoe and Truckee, and he tracked some of these glacial outburst flood deposits all the way down here. And so we're below the Truckee Meadows, the basin in which Reno sits, which is relatively flat. But here we're sitting on a terrace, maybe 10-15 meters above the river, that is just covered with huge boulders. Some of these boulders look like they're on the order of 6 meters on a side, 5, maybe that's an exaggeration, 5. I think there's one at least that's 6 or 7 meters. And most of these are volcanics, which you could argue, well, how do you know they came, that these are glacial outburst floods deposits? But there's also some granites in here. The granite boulders tend to be a lot smaller, but we'll find a few and I'll point them out. But these are actual boulders. There's lots of other sort of bouldery deposits along the way between Lake Tahoe and here. And so this is not, you can't view this outcrop or this deposit in isolation. You have to kind of view it in the larger context of deposits along this river, and when viewed that way, it doesn't seem that unusual. So it takes a lot of water, very high velocity currents, very large volume flows to move rocks of this size. I don't know the answer of exactly how large these flows were, but suffice it to say that they were pretty substantial. When these floods occurred, this river was probably graded to something like this level. There's also lots of smaller, finer gravel mixed up in this deposit of rounded clasts that are telling you they're fluvial or stream deposits. And so let's take a little look around here, and I'll show you some of the stuff I've been yabbering about. So first, you want to just orient yourself. This is Truckee River, and we're standing on the left bank. It's early January, so not much snow this year. That's one of the reasons I'm out here doing field work as opposed to skiing. And but it's a beautiful day, and there's lots of cool stuff to see. So here we are, we're on this terrace, and I'm turning back around so you can actually see these boulders in front of me. And if you squint your eyes, tilt your head just right, stomp your feet, you might even see a little bit of imbrication in this boulder, these boulders in front of us. These ones haven't been moved around by bulldozers or anything, so these are naturally emplaced. So let's walk around, see if we can find some granitic boulders. No, not there. But as we're walking around, you can see that this is a very bouldery field, and here's a granitic boulder. I'll put my toe on it. See, not that big, but still, granite doesn't outcrop within, the closest granite outcrops, as far as I know, are upstream from Reno. So that boulder had to have come from upstream of Reno, at least if it has tourmaline. If that particular granitic has tourmaline in it, then it may have come from Squaw Valley, because that's a characteristic of the boulders, of the bedrock in parts of Squaw Valley. And it's evidence that Pete Birkeland used to suggest that, yes, indeed, some of these rocks came from Squaw Valley that were eroded from the moraines that were blown out when the lake blew the ice dam and emptied and screamed down here. So there probably wasn't just one flood. Pete thought that during the Tahoe glaciation, which was the penultimate glaciation, that's when most of this action happened, and earlier. I think there's some evidence for some outburst flooding in the Tioga period, which is the last glacial period, something from around 25,000 to 10, 12,000 years ago. And so one thing we can say, now that we're up on these flats here, you can still see there's lots and lots of boulders. There's a Big Daddy. Here are my dogs. There's Indy, the golden boy, and Lucy, and you'll probably hear from them later. They always have an opinion. And one thing you can say is that Lake Lahontan, the level of Lake Lahontan was probably below this point when this deposit was laid down. Because no matter how much water is coming through, once that water hits the still water of the lake, all of this coarse debris is going to immediately drop out, and it's not going to go very far into the still water. And so at the time that the glaciers were at their maximum, at least represented by this deposit and the outburst deposit, and when the glaciers were at their maximum, this lake was not at its maximum level. So that's sort of interesting. It'd be kind of cool to try to trace these boulder deposits as far down the stream as we possibly can. I haven't done that. I keep waiting for the Nevada Bureau of Mines and Geology to map this river corridor. Hasn't happened yet. Still have hope, because there's some really cool stuff to see along here. So more boulders, and yeah, this is what an outburst flood deposit looks like. I'm sure they come in a few other flavors, but this is one of them. And just downstream, you can't really see it from here. If you look on Google Earth, perhaps, air photos, you'd see some sort of teardrop-shaped landforms that are sort of stretched out behind bedrock knobs or big boulder knobs. And those are also classic mega flood features that you might see along the paths of other large floods, such as the Missoula floods that came out of Glacial Lake Missoula up in Montana and coursed through the channeled scablands and on into the Columbia River. But also the Bonneville flood that came out of Lake Bonneville when the sill of Bonneville suddenly failed at about 18,000 years ago and sent out a few thousand cubic kilometers of water. A few thousand? A couple thousand? A lot. By comparison, these Tahoe yakulips weren't that large. Maybe on the order of 10 to 20 cubic kilometers, if that perhaps. But still, that's a lot of water, and probably forming velocities of, I don't know, tens of meters per second perhaps. Maybe that's an exaggeration. But discharges of many hundreds, thousands of cubic meters per second. It's a lot of water.